Okay, let's try the first question. They say there's carbonate, all right? Carbonate, if it accepts a H plus, it becomes HCO3 minus. Down. So accept H plus, it becomes HCO3 minus. Accept H plus, it becomes CO2 plus H2O, all right? Okay, so calculate the pH, right? Calculate the pH of sodium carbonate. So sodium carbonate is actually a base. That's why they give you a pKb, right? So you may ignore the effect of pKb2. So what it means is this: CO3, 2 minus plus water. It gives you HCO3 minus plus OH minus. So because it's a base, it's a weak base, the formula is OH minus is equals to square root Kb times C. So work it out, all right? So Kb is actually given to you already. So you have, since you have Kb, you can actually pKb, you can convert to Kb, which is 10 to the power minus 6.3, right? So plug it in, 10 to the power minus 6.3, and C is the concentration of the carbonate, and which was given to be 0.1, all right? So work it out. You should get let me see, the value is 2.23 times 10 to the power minus 4 moles per dm cube. All right, so you can find POH using minus log OH minus. Plug it in, you should get a value of 3.65. So you can find out pH. So pH equals to 14 minus 3.65, which is 10.35. All right, so that's how it's done. Okay, let's look at part B. 20 cm3 of a solution of sodium carbonate was titrated against 50 cm3 of hydrochloric acid. Calculate the final pH of the solution. So let's see how we do this, right? So maybe I just want to sketch it out a bit. So you start from carbonate, and then you're going to add HCl. So over here I have carbonate here, all right? Carbonate. Okay, carbonate will be neutralized twice by HCl, right? So because it can accept H plus one time and then can accept H plus another time. So since carbonate will react with H plus in a 1:1 ratio to form HCO3 minus, which is over here, HCO3 minus, all right? And then it can react with some more H plus to form CO2 plus H2O, okay, as shown from here. Okay, you can see form HCO3 minus and then form CO2 plus water. So since the concentration for the carbonate and H plus are the same, right, are the same, so which means the reacting ratio is 1:1, all right, which means the volume needed to neutralize the carbonate for the first equivalence point must be 20, all right, and then here will be another 20, so it'll be 40. You can see that? Okay, how I know it's 20? Because they react in a ratio of 1:1. So if the same concentration, they definitely need the same volume. So the question is asking for 50. So actually it's this point 50. Okay, so you have to take note at when I added 50 cm3 of HCl, you notice the first 40 cm3 of HCl has completely reacted. So there's actually only the remaining 10 cm3, okay, the remaining 10 cm3, which is this part here, actually remains as HCl. Okay, so let's calculate the number of moles of HCl at this point here, right? At this point it's actually 10 over 1000 times 0.1 to give you 0.001. okay, am I right? Yes, okay, moles. All right, so after that you have to calculate the concentration of HCl, which means you must divide by the total volume. The total volume is actually 20 cm cube plus 50 cm cube. That's the total volume at that point, so it's going to be 70 cm cube. All right, work it out. Okay, work it out. So you should get a value of 0.014 0.29 moles per dm cube. Alright, then from here you can find a pH, which is minus log H plus. Press your calculator, you should get a value of 1.845. Alright, so that's how it's done. Okay, so yeah, so actually I really sketched the curve. So actually, what are the important points that we are looking at over here? So we are looking at the equivalence point, right? The max buffer, sorry. These are the important points, right? These are the important points over here. So this is what you're looking at is this part, which is 30, and this part, which is 10. All right, we are looking at these 2 points. So those 2 points are what I call the maximum buffer. So maximum buffer, right? If you remember, max buffer, okay, max buffer, the formula is POH equals to PKB. All right, max buffer. So you can see that since I given you the 2 PKB value, right? Is that 2 PKB value? So say POH equals to PKB1, which is 6.3, which means POH equals to 6.3, which means pH is equals to 14 minus 6.3. That gives you a value of 7.7. Alright, so this is actually 7.7. Okay, the next max buffer, alright, you also can do the same thing. POH equals to PKB2, which is equals to 10.3. So pH is equals to 14 minus 10.3. That gives you a value of 3.7. Okay, so this is actually 3.7. Right? So these are the 2 important points that we expect you to actually write down. Okay. Alright, okay, let's look at the last part. 2 indicators are needed for this titration. The table shows the working ranges and colors of some common indicators. So for this example, okay, they are asking, state 2 suitable indicators for the above titration. So we need an indicator whereby it changes color somewhere around here and somewhere around here. Alright, so I guess for the first equivalence point, okay, for the first equivalence point, we're gonna use which indicator? The indicator must be somewhere between a value of 3.7 to 7.7. So I'm gonna use, I think I can use this. So the first equivalence point I can use bromothymol blue. Okay, bromothymol blue. Alright, so this is so this is the first suitable indicator. So for the second indicator, okay, for the second, to find out the equivalence point over here, alright, we need pH range that is below 3.7. okay, below 3.7. So I believe you probably can use methyl yellow. Okay, methyl yellow. Can you see that? Okay, so the color change would be when you use bromothymol blue. So the first equivalence point, right? You use bromothymol blue. So it changes from alkaline to acidic. So you must say it changes from blue to actually to green. Okay, where you get green is a combination between yellow and blue. Okay, that's the end point. Okay, so you could say green because the end point is where you have same amount of yellow and blue, you say it's green. Okay, for the second equivalence point, you're going to use methyl yellow. So the change in color will be yellow to, yes, yellow to orange, not yellow to red. Yellow to orange. All right.